Thank you. Welcome to Devly, a multi-service development environment. I'm Eric Hodel. I work at Fastly in the developer engineering department on our development environment, which I'll be describing to you today. I've written lots of Ruby code, some of which you use every day, and I'm co-presenting.
Hello, my name is Ezekiel Templin. I am at EZKL on most places on the internet. I've been writing software of one kind or another for more than 20 years. We currently work within Fastly's site reliability engineering organization, focusing on the improving internal Fastly engineering experience. Fastly, for those of you that don't know, is a content delivery network and edge cloud provider. Fastly serves traffic for GitHub, New Relic, Spotify, and many other popular websites and services. Fastly also provides service for all Ruby and Ruby Gems downloads, and does the same for many other open source projects free of charge. Ask us after the talk if you're interested in using Fastly for your open source projects. We're more than happy to sponsor. We have servers all over the world which serve more than 14 trillion with a T internet requests each month. This constitutes more than 10% of all internet traffic. And so today we'd like to discuss a problem that we believe impacts organizations of all sizes. To help us illustrate this problem, I'd like to tell you a story about the evolution of Fastly's API. So this is a rough approximation of the service architecture that backed the Fastly API circa 2012. The original Fastly development environment consisted of a copy of each component of the Fastly API running on each engineer's laptop. Soon after, the early team decided that virtual machines should be employed to provide a degree of operational uniformity and parity between development and production. Another attribute of Fastly in the early days was that all of the engineering work was being done by a very small group of people. Changes to systems were easily introduced and distributed through source control, which allowed the team to rapidly develop and deploy changes. Another side effect of the small size of the company was that focused discussions were possible. This made decisions easy to communicate. Let's zoom back in and step forward in time a few years. Fortunately for us, the company was successful. And that success opened doors for new opportunities that expand the business by adding additional functionality to our API. In some cases, when we added new functionality, we added new supporting systems. And when we, as software engineers, add new functionality and dependencies to our systems, we introduce complexity. I don't mean to imply that complexity is necessarily a bad thing. To the contrary, we would argue that complexity is an unavoidable side effect of growth. There is something else that I haven't mentioned yet that complicates matters even more. We like to use the right tool for the job, so many of our services were written in entirely different languages with very different workflows. Can I see a show of hands of how many people have worked on systems that look like this? Right on. Okay, cool. So despite the increase in the number of languages and services, our development environment stayed much the same. Moreover, the gaps between each group's development workflows grew considerably as well. This became increasingly problematic as our engineering department doubled in size every 6 months. As a result, our original development environment became increasingly unreliable, and the established processes to communicate changes broke down. Maintaining any single engineer's environment became more and more time-consuming and led to unnecessary conflict. We have engineers working on everything from code that runs in the Linux kernel to code that runs in the browser, and the needs of each team in these different areas are dramatically different, and our original development environment was unable to meet the needs of one team without compromising the needs of another. This growth continued regardless of our development woes. Writing and scaling software is complicated. There are many moving pieces and things to keep in mind. However, as an industry, we've established and continue to improve upon strategies that can help us direct our time and energy. I believe this is due in large part to our ability to observe software systems in isolation. Organizations, on the other hand, are far more complex and much harder to observe in systematic ways. But by introspecting on our own experiences and listening to our coworkers, we were able to find themes and common frustrations, such as the ones you see here. These are discussions, sort of paraphrased discussions of between engineers early on at the company. How many people have seen things like this or have said those things? Cool. So yeah, to a new hire, here's your laptop. We'll see you in 2 weeks when your development environment is running. Does anyone know why the API gateway crashes in a loop? I updated the rest of my development environment and now nothing works? I can't do my work today because I need to rebuild my development environment. So the development environment was clearly untenable and only becoming more problematic. Moreover, our friends and coworkers were becoming increasingly frustrated. But what to do? During the same period of time, many new tools like Docker Compose and Minikube were released, but none that met all of our needs. So through observation, research, and a lot of discussion with our friends and coworkers and peers in other companies, we arrived at a few important themes. One sec, sorry. Yes. So we believe these themes embody the traits of desirable, developer-focused productivity tools. A development environment must be reliable. I should be able to run a small number of commands to get what I need running. I should not have to know how every system works to do my job, and I should be able to easily see the local health of systems I rely upon. I should never have to spend a day rebuilding my development environment. A development environment must be accessible. Maintainers of systems must be allowed and encouraged to maintain their development environments collectively. I should be able to build and test new changes across systems owned by different teams easily. A development environment that spans multiple teams and workflows must be maintainable by the community of folks using it. Managing changes in source control illuminate past and present ownership, even with many components. Structure and form should be encouraged through convention and documentation, good tooling, and feedback loops, rather than enforced by gatekeepers. We want our development environment to be able to run discrete services together in composable units. It should also be easy to try out new supporting systems. A development environment must be reproducible. We need the ability to determine and apply the last known good state of all systems. Source control and similar mechanisms should allow us to determine how we arrived at the last known good state. We should be able to leverage existing tools like Git, Ruby Gems, Perl's CPAN, Python's pip, and Golang's dep. So throughout the rest of the talk, we hope to show you how we've started to meet the needs of our coworkers at Fastly by applying these themes to a tool that we've been building together for the last year. We call the tool Devly. To tell you more about Devly, I'd like to hand things off to my friend, close collaborator, and lead engineer on the Devly project, Eric Hodel.
Thank you, Zeke. I will talk about Devly and some of its components and features. As Zeke covered, Devly is designed for developers. Devly builds images from your repositories. It uses those images to manage containers, and it enables communications both within and across teams of developers. Devly is distributed for macOS and Linux. We provide a standalone executable built by RubyPacker and provide packages for macOS and Debian. Devly lets you configure all of your services. It helps you build images from your repositories using Docker files. It allows you to configure those images to run as services. And it allows you to run groups of services together as part of a rack. An image contains the files necessary to run a service. The audit log image uses Ruby, so it has a copy of our application code. That code requires some libraries like Rails, Sidekick, and a JSON parser, so the image contains those installed gems. The JSON parser requires a C library, so we install that with the OS package system. In our repository, there is a Docker file that contains the instructions for building this image. Images can contain applications for any language. Our stats service is written in Go. Its image has a Go binary compiled from the stats application code. The web app our customers use is written in Ember. This image contains a copy of the application code ready to run. We share these images across teams by uploading and downloading them from the Google Container Registry. This allows us to be sure we're always using the images built from the latest source code. A Devly service is a runtime configuration for an image. Here we've created the audit log service using the audit log image. A service runs a command. Since the audit log service provides an API for managing event data, it runs a Rails server to provide the HTTP interface for events. Our audit log service needs to be accessible to other services so they can read and write events. To allow other services to communicate with us, we expose port 8888. If you use a framework like Rails that supports live development, you can mount your repository on top of the files inside the image. This allows you to work with your favorite editor from your favorite OS. You can change a file on your host OS and see the changes in the browser. The service runs the audit log API, but we also have some Sidekick background jobs to run. To make it easier to read our logs, let's use a separate service to run these background jobs. Since the background jobs all use the same models and databases as our application, we can use the same image. We create the audit workers service, but we run the Sidekick command instead of the Rails server command in the audit workers service. Then when we start up the audit log service, it only runs the Rails server. And when we start the audit workers service, it only runs the background jobs. This separation makes development a little more accessible because the logs are separate. We can also test our audit workers in complete isolation from the API. We'll create a few more services for our applications, including the authentication API, the configuration API, and some databases they use. If we're going to work on the configuration API, we don't want to start up services we don't need, and the same for the authentication API. We can create a rack for developing the configuration API that only contains the services it needs. We need a MySQL database, the audit log, and the config API services. A rack can customize a service. Since we want to access the services running inside the rack for development, we expose ports for a few services to the host OS. This allows us to connect to these ports in the browser. You can also set environment variables or mount different files to change the behavior of a service. Devly allows you to configure multiple racks. The authentication team needs to work on its services, which include the Postgres database and the authentication API. The authentication development rack also uses the audit log service, just like the configuration team. When we start these racks, they use independent containers to run their services. This allows the teams to have different configurations and software versions for the audit log service that won't collide with each other. For example, you can start up both racks at the same time to isolate bugs that span multiple services. Using common configuration to replicate services across teams makes sharing your work easier. The configuration for the images, the services, and the racks are stored in the shared Devly library repository. At Fastly, we allow any developer to make changes to the Devly library and have them discuss proposed changes with the people that develop those services. The authentication, configuration, and audit API teams all have racks using the audit log service. When the audit dev team proposes changes to the audit log service, all of these teams need to be able to discuss them. By tracking the connections between teams and services through the Devly library repository, they become more visible, which improves the maintainability of your services and the communication across teams. Now that we've had an overview of the components of Devly and how they combine, I'll show demos of common development tasks using Devly from the perspective of developers on the various teams you've just seen. We'll run through some workflows like getting started with development, sharing changes within and across teams, and set up some convenience tools that will make development easier for ourselves and our coworkers. Let's start at the beginning by setting up Devly as a first-time user. We run Devly setup and give a Git repository to pull a Devly library from. This downloads the Devly library repository and other repositories for our services. Along with checking out repositories, setup performs some additional checks, including your Docker version and your Google Cloud SDK version. The setup command will try to fix things it can, or give you a message to help you fix the setup if it can't do that for you. This step takes no more than a few minutes to fetch your repositories and perform the necessary checks. Once setup completes, we can run Devly info to see what racks and services are available to us. Devly will give us a list of racks and the services that are in our Devly library. We can retrieve information for a rack, which includes the services it starts, and we can retrieve information for a service, which includes the image, the repository, and metadata for ensuring the image is compatible with the files in the repository and is up to date with the registry. Now that we have completed setting up Devly, let's start a rack and perform some basic development tasks like viewing logs, using our service, and making a small change. The Devly up command starts a rack. Since we don't have all the necessary images downloaded from the registry, first we see Devly pulling one of the images. Once all of the images are downloaded to the Docker on our host OS, Devly creates a network to isolate this rack and starts all the containers. When containers aren't dependent upon each other, Devly can start them in parallel to speed up startup. Now let's check to see if everything is running okay. We use Devly status to see which racks and services are currently running. We can see that the two API services and the database are running. And we can see the two API services are accessible on the host OS on ports 8888 and 9999. We can view the logs for this rack by running Devly logs. This command will continue to follow any new logs until we exit with Control-C. Since everything seems to have started for real, let's try out the configuration service by switching to the browser. The configuration service was running on port 8888. So when we load it, we see the main page for the configuration API. Now we're triple sure that the rack is working. Let's switch back to the terminal to view the logs for this request. Devly logs shows our HTTP requests from viewing the config API main page. Everything is definitely working. So let's do some work by opening up the main page in our favorite editor, Vim. We open the source code for the main page from the host OS and add some text. This is an example service. Because no one has figured out how to exit Vim, we only save the file. Let's switch back to our browser and see if the change worked. Reloading the configuration API shows the text, "This is an example service" has appeared. Our change was successful. Let's check the logs to see if it wasn't fake. And of course, the requests from the refreshed page appear in the logs. Since this was a 200 response with a different page size, we definitely loaded the new content. Now that we've done our work, let's shut down the rack by running Devly down. This stops all the Devly containers we had running. This might save me a little bit of CPU power, but normally our services at Fastly are lightweight, even when starting a rack with a dozen services. When we work within our team, we'll be pushing and pulling changes to our team repositories. When we work across teams with Devly, the other team will push images for their services when they have a new set of features ready. For this workflow, the audit team has updated the audit log image to add a source field for events, and we need our services to use this new feature. First, let's see if we already have the source field by loading the audit log service in the browser. I see the user ID, the timestamp, and the actions fields, but no source field, so we're using the old audit log image. Let's switch to the terminal to update our service. Since we verified we don't have the source field, we'll pull the latest image, and sorry about the lack of output, it's a bug. Our running audit log service is still using the old image, so we need to shut it down and start a new image. We can do this with Devly restart, which will replace our audit log service with a new one running the updated image. Let's switch back to our browser to see the updates. We refresh the audit log service in the browser, and we see the source field has appeared as we expected it. Now that our audit log service is running the latest image, we can continue updating our service to use the source field in the audit log. So far, we've worked outside the container. Sometimes we need to run commands from inside the container where all our dependencies are loaded. Let's pretend we're on the audit log team now and go back in time a bit. We're now working on adding the source column to our database. To do this, we need to run the migration we've written. We can't do this from the host OS because none of our application's gems are available. They're only inside the container. So we need to run the migration from inside the audit log service. Let's start with the browser again. We view the audit log homepage, and of course we don't have the source field because we haven't run the migration. Devly exec lets us run commands inside the container. We don't remember exactly how the image is laid out, so we start a bash shell so we can explore. After the shell is open, we remember to change the audit log source directory, then check to make sure we're in the right place by running *T. Then we run the migrations. We see the migration said it added the source column. Let's go back to the browser and check it. Reloading the page in the browser shows the source column migration is complete. Now that we've remembered where the rake tasks live, let's run the command directly so we can use our shell history in case we need to roll back and retry the migration. So we switch back to our terminal and run our migrations using devlyexec with a complete rake command line. This is a little better, but it's really only okay for this one task, this one time. When we share our work with other teams, how will they remember how to run our migrations? What we've done is not very usable, and it would be nicer if migrations ran automatically when we started a rack, so we can get to work right away. We can automate running the migrations at rack startup using a post-build task. The post-build tasks run for a service after the rack starts to perform any extra setup you need, like migrations or seeding data. This lets users who are unfamiliar with a service get to work right away. Post-build tasks live in Devly library and are built as rake tasks that devlyup runs. The tasks live in the post-build namespace. The task is named the same as the service it will run for. The rack argument allows Devly to run migrations on the correct service if you have multiple copies running in different racks at the same time. Here we'll run devlyexec on the audit log service, just like we saw running the migrations earlier, and we use the same rake command to run the migrations. After shutting down the rack, we can start it again with devlyup. We go through all the steps we saw before from the starter rack section. Then at the bottom we see devlyexec run our migrations, including the migration output. Now, whenever someone starts our service, the migrations will run automatically, so they don't have to look up what to do. Of course, we still need to run our migrations during development the next time we want to change the database schema. Shutting down and starting the rack takes several seconds, and we don't want to waste all this time. To make this easier, we can save the long devlyexec migration command as an easy-to-run command. We don't want to have to remember or look up or type this long command to run migrations. Let's give this command a friendly name that's easy to type and remember. The saved commands live in the Devly YAML file for the repository we are working from. Here, the audit log repository. Each repository can have its own Devly YAML with its own custom commands. Let's zoom in to look closer. The run commands are a collection of friendly command names for us to run. I chose audit migrate as the name of the command with which will run the migrations. The command runs on the audit log service, and the command line is the one we've seen, which runs the database migration tasks earlier. We can define a test command to run the tests inside a service. This way, anyone can run the tests where all the dependencies are up to date. So now we can run devly run audit migrate from the audit log directory, or we can run the tests. Since these tests are inside a container, which is running as part of a rack, they may communicate with other services in the rack. You can have separate racks where one is configured to run unit tests that don't talk to other services, and a larger rack with more services for running integration tests. Either test suite could be started from a saved command. Sometimes we have to work on a service together with another team, and Devly has a workflow for cross-team development. The audit log team is working on some new high-security features. Their work isn't complete yet, but they want our feedback before they continue and make something that's too difficult to use. To give them feedback, we need to work with their work-in-progress branch. We were told if we went to the audit log page, we would be running the correct code if a high-security logo appeared. We go to the audit log page and see the same one as usual. No high-security logo anywhere, so we'll need to switch to their branch. The high-security branch may have new dependencies our image does not have. We can't mount a copy of the updated branch on top of our image because without the updated gems, the code won't work. We'll need to build a new image to be sure everything will work. To build the new image from the high security branch, first we need to tell Devly to use a repository we control. We use Devly link to tell Devly about our copy of the branch, or our copy of the repository. This will let us build the image from the correct branch. We see that the audit log repository inside our Devly library points to our copy now. Next, we change to our repository copy. We check out the high security branch. Then we use Devly build to create a new image for the audit log service. Now that our new image is built, we can restart the audit log service. We use devly restart again like we did when we pulled the audit log image that had the source field. And now we reload the browser, or when we reload the browser, we can see we're using the high security branch because the high security logo is present. We can do some test integration with the new code to give feedback to the audit log team on the high security features. As adoption of devly increases, we'll want to centralize image building through continuous integration, so you can always have up-to-date images in the registry. By running your tests through devly, you have a more consistent environment because the image, service, and rack are all built and configured the same way in both the continuous integration and local development environments. Regular devly setup may take too long in a CI environment as it performs more checks and retrieves all of the devly library history. The CI mode for devly reduces the history and repositories fetched to save time. The CI environment has our repository checked out to the correct commit already, so we can use devly link to use the correct source files. The overwrite flag makes sure we replace any existing files. The new code we're testing may have new dependencies, so we need to build a new image, just as we did with the high security branch. Finally, we start the correct branch for testing this service. Then everything will be ready to run tests, same as in our local environment. The next thing to do is to run our tests. This uses the same saved command we saw earlier. If the tests successfully pass, and we're on the master branch, we can then push our new config API image to the registry to share this image with all the teams. Adopting devly has given us a common way to start more and more of our services. Once you have a sufficient set of teams using devly, you can build on top of this capability beyond the workflows I've demonstrated. All the workflow demos I showed were for Ruby applications, but they are no different for developing a Go application which runs a compiled binary inside of an image. With a Go app, you edit the source code, create a new image with devly build, then test it with a saved test command. This makes the development process more accessible, as you don't need to learn as many new things when working on different languages. I've already shown the basics of CI and devly, but with a common way to start services and run their tests, you can go beyond running the tests for a single service. The services you build are composable into larger racks. The more services you have in a rack, the closer the closer to a real deployment you come, so the easier it is to run integration tests or end-to-end tests across your services. By ensuring that your images, services, and racks are reliable at every level, you can more easily move your containers towards deployment. The image as the base of all your services makes the content of any application accessible to various security scanners. This allows you to run vulnerability scans of the libraries in your images or find issues with static analysis. You can perform enhanced testing, such as a rack for fuzzing, to provide bizarre inputs that try to break a service. You can get started with chaos engineering in an isolated, stable environment, and you can build separate staging environments for groups of services or to run integration tests. And now Zeke will talk about some things we've learned.
Thank you, Eric. So some of the things that we've learned, one of the first ones was that finding early adopters is really important. We were fortunate enough to have a diverse group of early adopters with varying degrees of experience who were willing to provide us with constructive criticism very early on. We had a few early adopters with previous container experience who were able to provide us with feedback on our containerization and orchestration strategies. We also had a few adopters who were relatively new to Fastly and who had little or no previous container experience. And all of our early adopters helped make devly a better product early on. Since one of our major goals was accessibility, the perspective of the new employees without very much experience with our systems was key. You need to build your community. On top of the feedback of our early adopters and their advocacy helped increase the internal adoption from 5% of our product engineering groups to a little over 50% in about 6 months. With that kind of adoption rate, we learned the importance of building and sustaining an open, supportive community very early on. Talking openly about our plans, successes, and especially failures was very important. As of today, our devly library repository has 30 contributors and includes people from almost every team in Fastly engineering. All this fosters a sense of shared ownership and togetherness. Once your community is in place, build processes to ensure that you are taking feedback into consideration and communicating effectively. The more heard people feel, the more likely they will be to talk, ask questions, and provide feedback. We acknowledge, discuss, and ticket bugs our users find quickly. When we fix them, we let the people who reported them know. Documentation is really key, especially good getting started documentation. It reduces friction, but it does need to be maintained. Documenting the workflows you use as well as the ones that you observe other teams using. Make sure that your users know that they are free to update documentation if they want to. This is part of the sharing of this tool. You also will want to document administrative tasks and release processes. You'll be glad that you did, because it turns out that QA automation and release engineering are very hard, especially for a cross-platform CLI. Despite the Devly CLI having the Ruby code of the Devly CLI having 97% test coverage, we find bugs in weird state-specific edge cases all the time. That said, automating our release processes has proven to be a real time saver. We've also started extending both the tool and its test harnesses to check for and report common issues around rack schemas. We regret to say that Devly is not yet open source. Supporting our users at Fastly and preparing for this conference did not allow us the time to prepare Devly for an open source release, but we are very close. So we just want to thank our reviewers at Fastly and our partners and some folks from outside the company for reviewing this talk and also for helping us to kind of develop the tool. Here's some credits for the Ruby logo and Perl logo and Go logo for various intellectual property peoples. Thank you.
For bringing such refreshing introduction to Devly. I myself am very looking forward to it. Okay, so now at this time, QA time, is there anyone wanted to ask a question? There?
So yeah, I'm relatively new to programming professionally, so I'm not too familiar with the tools that are already out there. But from what I saw from this talk, would it be fair to say that Devly is basically like Foreman plus Vagrant or Docker? Like, does it fulfill those two roles, or is there something more?
It's very, very close to that. So on Mac OS, we're using Docker for Mac, and which is effectively is very, very similar to sort of how Vagrant works by running a virtual machine that has Docker and all these things, and then exposing the networking layers and the ports, sort of mapping it through to the operating system. I guess the Foreman component is sort of handled by Docker itself, and that it's running your processes, it's exposing those ports, but it allows you to have more fine-grained control. But yeah, it's very, very, it's analogous for sure. Yeah, thank you.
Anyone? There?
Okay, so we can, this is recorded, I probably, okay. I'm sorry to our lawyers right now. So a little over a year ago, I was previously, I was a VP of engineering at Fastly, and we ran into a lot of problems with our development environments, as we sort of discussed. And I decided to change my role. Unfortunately, the company supported me in doing that to begin to solve some of these problems more directly. And at the time, a person in my life was starting up a company that was very much based on Docker, and so I was helping them learn how to use it and learned it myself, We had a 3-day hackathon at the end of 2016. And so because I've been at the company for about 5 years and knew a lot of the systems, I spent that 3 days basically taking some of the core projects and turning them into Docker containers in a very hack-and-slash kind of way. A couple months after that, we ended up being able to use it to test a pretty large operations sort of experiment that we were doing. And the combination of that and several people in our engineering group deciding that it was better than the existing thing for a new project kind of got interest from our executive management. And then ultimately, I started giving talks internally at the company about it, and using my amazing personality, I'm kidding, of course, but really trying to show people that this was actually a thing we could use, and fortunately, again, the company was supportive. I should say that the majority of the work on the CLI itself is being done by the two of us, and I would actually say that he has done the majority of it, and so it's a very small group of people doing this. But we did have some really great support internally to make it happen. Yeah.
I think additionally, we picked the right group to start with, where it was people that Zeke knew very well, and they could say, hey, how about you try this thing out? So it was as much political work as it was technical work to get started. So if you pick a team that you don't work well with, it probably would not be as successful as starting with your friends.
We also have some very interesting compliance and regulatory issues because of the amount of traffic that we serve for a lot of different companies all over the world. And so we were able to get buy-in from our security and compliance people by basically beginning to start the conversation about immutable infrastructure and the fact that we can do much more enhanced testing, sort of what he was talking about, and analyzing the code that's actually being shipped into production, there's some really, really interesting stuff there that even companies that are much larger than ours, like Google and Microsoft and Red Hat, are really beginning to dive into and say, like, this is something that we need in the industry. GDPR and things along those lines are becoming much more active conversations, I guess.
Anyone? Okay, so maybe it's time to thank Dan again.